Welcome everybody to another edition of the AnandTech podcast. This is podcast 41. I'm your host, Ian Cutress. And today's podcast, we've got a guest on. I'd like to introduce Patrick Kennedy. Patrick Kennedy is the editor-in-chief of ServeTheHome. And between AnandTech and ServeTheHome, we pretty much cover a good chunk of the server market, I think, between us.
Yeah, thanks for having me, Ian.
If you're interested in any of our server content, we reference Patrick quite a lot because he tends to have hands-on with lots of stuff that we don't get to play with. I've known Patrick for a few years now, and dude, your setup is crazy. I've seen your server rack in the Colo, and it's just filled with systems of stuff that I wish I had access to.
It's grown quite a bit over the last year as well.
Well, yeah, you said recently you upgraded everything to 40 gigabit Ethernet.
Yep, and then we will be moving to 2550, 100 Ethernet within the next 6 months as well.
Obviously, to anybody in the consumer space, that sounds like, why would anybody need that amount of networking? Why would anybody need, you said earlier today that you had, 1,200 cores?
I think we're getting closer to 2,000 between the four racks.
What do you do with 2,000 cores?
So we have a portion of our editorial side, which we do reviews in terms of server platforms. On the other side, we also allow folks, after we do our reviews, to jump on the same systems that we reviewed, and they can actually try them out, run their own workloads, whether that's a AI machine learning workload, whether it's a storage performance workload, you name it, they can do that on Demo Eval.
One of the reasons why I've got you on, given the fact that I just happen to be in the same area in which you live and work this week, is that there have been lots of goings on in server news and embedded, all relating around Intel's Atom designs, specifically the C2000 series of Atom cores. Now, the C2000 been around for 3.5, 4 years?
Yeah, so Avoton and Rangeley were the first C2000.
Avoton, yeah.
Were the first C2000 platforms that were released in September 2013. And the interesting part about these systems is that they have, in general, worked very well across different systems, everything from network-attached storage appliances to firewalls. They also power the control planes in many of the high-end switches, so the 1040 gig switch
actually have these 20-watt parts. I mean, back when they first launched, I know both of us did reviews of ASRock's C2750 D4i motherboard, which at the time was a mini ITX motherboard with 8 cores supporting 64 gig of RAM, but had 12 SATA ports because it used Marvell controllers, and that offered a really nice sort of home build NAS type operation.
And that system actually, or that platform actually found its way into several OEM systems, such as the FreeNAS Mini and Mini XL from IX Systems, which is very popular among server guys.
Yeah. Well, and they did that from 2 cores to 8 cores, the whole Avoton C2000 range. Was it up to 20 watts, or did they do a 45 watt version in the end?
They only did 20 watts.
Yeah, it's been out for so long.
Yeah.
You can barely remember. But the news that's come out recently, I mean, I highly suggest people go read Patrick's piece on it because you've been doing most of the legwork on this, regarding a bug in the chip. Is it a bug in the chip, or is it a bug in the BIOS, or?
So from what we have heard, it is a bug in the silicon. So there will be a eventual silicon rev to fix the platform. There's also a platform level fix, which involves more of a motherboard fix.
Well, these are embedded chips anyway, so typically it's just you rip it out and you stick in a new one.
Right. So in the embedded platforms, you can't do that because the chips are actually soldered onto the motherboard.
Well, no, you just take the motherboard out and stick a new one in, yeah. But the issue is critical.
Right. So the way that it manifests itself is that you'll have a system, the system will die, and when you try to turn the system back on, it won't post.
So death.
So it's dead.
Yeah.
And from what we've gathered, we've talked to large web hosts that make their own systems. We have talked to various vendors. And from what it sounds like, it is not a problem where, 10% of the systems are failing at 18 months or 10% of the systems are failing at 36 months. The numbers seem to be much smaller than that.
And I mean,
it's small enough, we'll put it this way, it is small enough that most vendors are telling me that they are not even seeing any major discrepancies in terms of Avoton and Rangeley platforms failure rates versus others.
So it's all down to a fuse that nothing's officially been published on this.
Right.
Exactly what it is. But it's to do with clock generation.
Right.
And that completely knocks out how you generate clock. So therefore, if you can't generate a clock, you can't even turn the system on.
Right.
But the fact that it's not statistically affecting failure and return rates.
So I'll tell you
is this really a big thing if it doesn't affect failure rates?
So it is affecting failure rates, and probably the biggest impact that this bug is having is if you were to look at a company like Cisco, which was very proactive, although they didn't name the exact source of the issue or the source component, we have learned what it is. Cisco has all these managed service providers that are installing Rangeley firewalls into their customers, and they're basing their pricing models on they will not have to go service those firewalls for years.
Yeah, so for 5-10 years.
And what's happened is because of this faulty component issue, Cisco is going to be replacing those. Cisco is going to be replacing those systems so long as you had an active support contract around the middle of November 2016.
Yeah, it's 2016. I know it's been a busy time.
November 2016. And so the implication of that is that all of these managed service providers that have these systems deployed are going to have to actually go out and spend the labor to go into the field, go to their small, medium business customers and replace those components. And so the biggest impact is not necessarily just from the failures. It's actually from all the businesses that have to go service these systems in the field.
And it's quite big business as well.
Yeah, and the Avoton and Rangeley, specifically the Rangeley parts, were used by a myriad of vendors. The number of vendors that actually use these, whether it's in their switching products or embedded products, it's almost countless.
So with the range of vendors, obviously, there's been a range of formal responses to this issue.
Mm-hmm.
Some are giving extended warranties and will only replace it if you report an issue.
Mm-hmm.
As you say, Cisco with some of the stuff is actually going out and replacing in advance of any issue occurring. What are other people doing?
Yeah, so you have companies like Supermicro that will RMA systems that are either in warranty or we've heard a little bit out of warranty. You have vendors like Synology that are extending warranties on systems that were potentially impacted. ASRock is an example of a company that will actually replace systems so long as they fail under warranty. IX Systems, we mentioned the FreeNAS Mini. The IX Systems team will actually extend the warranty of their products in the event that there's a failure, that they'll replace them. So that tends to be the most common way that we're seeing this being handled. And just the overarching message here is really that these are not failing at 50% of the systems are not failing at a annual rate. It's a very small percentage.
But stuff needs to be done. Does it essentially affect Intel's reputation to have failures on such a scale?
I think it does impact Intel's reputation. On one hand, Intel had a major failure, and they're taking steps to fix that failure, and they're doing a really good job in terms of getting vendor support. We understand, though, that the vendor support is coming at a price, and from what we can tell, based on the responses that we've seen publicly, it looks like Intel has NDA'd most of their vendors into not talking about the problem and the fact that they were the source of the problem, so that information really doesn't
Has Intel actually said anything on the record, public, about this?
They did in their most recent earnings call.
Okay, yeah, just a brief sort of...
Just a brief,
one. Yeah. But it's great that you've been digging, and I assume more information is going to come through. Which is interesting given that Intel is officially launching the next generation of this product.
Yeah.
So officially announcing it this week, though it's actually already been on sale for a month. It's kind of weird. This is Denverton, or the C3000 series. Patrick has actually posted benchmarks on this platform managed to get hold of a unit, or actually get able to test a unit. So Avoton was based on Silvermont. These are based on Cherry Trail cores. So this isn't the latest generation Atom architecture, but it's because of the way it's deployed, it has to be certified and registered over a long product cycle. We're going to see C3000 based in 2 to 16 core variants.
Yes.
It's going to have things like increased networking, dual 10 gigabit support. It's going to have quick assist technology. One new feature that's coming to Denverton is high-speed I/O lanes. So for anybody who's familiar with on the consumer chipset side knows that Intel's Z270, Z170, and I think the Z97 chipsets, they have 24 PCIe lanes which can be configured to either PCIe, SATA, networking at the discretion of the motherboard manufacturer. That now also comes to the Atom range, the C3000 range. So come on, you've had some benchmark data. What did you get and what did it say?
Yeah, so one of the things that you'll see with Denverton and the Atom C3000 series is that the per core performance has gone up drastically. I think Intel is going to publish numbers along the lines of 2.3 times the performance of previous Rangeley generation parts. We've also tested specific applications such as AES acceleration, which is really important when you're doing VPN.
Yep.
And those numbers can be 3x in terms of what we were seeing from previous generation chips. So the performance improvement of the Atom C3000 series is dramatic. And combine the fact that you have a per clock performance improvement with the fact that you're moving from a maximum of 8 cores in the Atom C2000 series to a maximum of 16 cores in the Atom C3000 series, and you have a recipe for significantly more performance in the embedded space.
More power?
Yeah, so the higher end chips are going to run at over 20 watts from what we've heard thus far. Although a low end C3338 chip will run at about 8.5 watts.
Yeah. Actually, so the C338 chip, that's currently on Intel's CPU database, the public one, and has been the one that's actually been on sale for a month before today's announcement. Intel didn't announce any SKUs along with this, just the fact that the family is officially launched. So we don't know how many SKUs are coming out. We know that it's 2 to 16 cores. We don't know exact frequencies. We don't know exact power consumption. I assume at some point they have to make this information public, but it will be a slow rollout. Yeah, so as you understand.
Right. So what we think is going to happen, and we've already seen evidence of this with the first parts coming out in early January. We expect that the larger 16 core parts are probably going to push a few more months into the future before we actually see them for sale. And then the other important fact on these embedded products is that there's usually a lag between when Intel announces the availability of these chips for sale and when we actually see them designed and into products and sold at retail.
It's completely different from the consumer space because you have to wait for the vendor to buy the chip, have the chips on sale for them, then buy it, then design the platform around it, and then put that and qualify that for sale.
Right, and these platforms typically are designed for 7 to 10 year lifespans. Yeah. So given that, there tends to be a little bit more testing than would go into a typical consumer desktop.
Yeah. I know that Ganesh is keeping tabs on all the major NAS guys because obviously everything that used to be previous generation C2000 is now going to move to a new generation C3000.
And one of the things that you saw with the previous generation C2000 was that the NAS guys did not necessarily implement the C2000 series immediately upon launch. It actually took many months until they were able to design it and actually sell systems based on the C2000 series.
Despite everything you said with performance increasing with the new cores and the fact that it's now got 10 gigabit Ethernet capability, Does it impinge on the Xeon-D market any, do you think?
Yeah, so we have already seen in terms of benchmark data, when you have multi-threaded applications, a 4-core Atom C3000 series can be competitive with a 2-core Pentium D 1508.
It's called Pentium D, but it's still a Xeon D.
It's still Broadwell D.
Yeah,
that's right. And so, we there will be some overlap, but there are some key differences between a Broadwell core and an Atom core. One of the biggest ones is the fact that the Broadwell actually has level 3 cache on board, which is something that you will not see in the Denverton series.
It's going to be interesting to see as they come out, and we're going to test, you're going to test. But talking about Xeon-D, along with Intel's announcements today, we have new Xeon-D focused on networking.
That's right.
Yeah, I mean, don't get me wrong, the press announcement on this was really vague, but not exactly naming an exact new SKU number, just that this is a new Xeon-D, still based on Broadwell, so no Skylake, but this has increased networking capabilities.
Right, so what we're seeing from Intel is a new Xeon-D networking-focused family, where you're going to actually have 4 10-gig Ethernet connections on the package. You're also going to see Quick Assist, which is something that I think a lot of folks were expecting to see, or you're going to see Quick Assist, which is something that a lot of industry observers were expecting to see in the Xeon-D 1518, 1528, and etc. embedded models. But we're finally getting Quick Assist acceleration with Broadwell D.
What's Quick Assist?
So Quick Assist does a number of things, such as it accelerates encryption technology. So if you're using OpenSSL 1.1 and later, you have the ability to use a Quick Assist module, which will greatly offload from the CPU cores a lot of that expensive
it's essentially dedicated IP for specific workloads.
Right. And then there are other workloads that it encompasses, such as compression, so you can actually use the Quick Assist compression engine and decompression engine.
So, say, for example, if you're transferring video.
That's right.
Yeah. So, Xeon-D with Quick Assist, 4x10 gig, but not a lot else. Well, I think by the time...
I think that this product is targeted at the second half of 2017. And so This was a very early announcement by Intel. We're still at least 4 months away from the second half. And so I think that it's something that we're going to hear more about in the future, but this is kind of a preemptive move by Intel.
So IDF in August, that's second half. Supercomputing in November, that's second half. More details then, I guess.
There are a lot of opportunities. And then with the embedded parts, they don't necessarily
embedded world.
They don't align launches to major events oftentimes. So, for example, the Atom C2000 series was launched in September of 2013. The Xeon-D series, I think, was March of 2015. And so, from a standpoint of, they're not around major events that we would normally associate with consumer or big Xeon product launches.
Yeah. So while I have you here, some information coming out about AMD's next server platform, Naples. It's still fairly under wraps. And, we saw demonstration platforms last year at August, and not a lot has been said since apart from expect something Q2, Q3. So Naples is using AMD's new processor microarchitecture Zen in a chip that's meant to be many cores and many memories and many PCIEs. I think they said up to 32 cores, and we looked at the motherboards and it looked like there was up to 8 channels of memory and at least 64 PCIe lanes. AMD have an opportunity here, right, with their server platform. There's been nothing for 5 years. I mean, you were telling me today about trying to get hold of some old Opterons years and years ago.
Yeah, so I think AMD has a very exciting opportunity to capture significant market share. There's
when you say significant, a scale. Are we talking 2%, 5%?
Several percent.
Several. Okay.
And the reason for that,
That's still billions of dollars.
right. So there is a large opportunity for Naples, and where Naples has a very exciting opportunity is really in the general web hosting segment that is huge. I mean, there are web hosts that are running dedicated servers. If you're running a WordPress site or many WordPress sites, you're running forum software, you're running database software. There's this giant web stack. And in terms of what AMD is able to offer, is they can offer something that for the first time in 5+ years is an alternative to Intel. If you compare the AMD x86 architecture to something like an ARM architecture, when it comes down to actually using the platforms, the AMD x86 architecture will be code compatible with a lot of what we see on the Intel side, whereas the ARM architecture requires a lot of learning, a lot of recompiling software. And because of that, AMD has the opportunity to go into accounts that Intel has held and can immediately start selling chips.
So people who are considering ARM as an alternative to Intel can now look at AMD as not necessarily a stopgap, but a viable alternative with a lot less extra overhead.
Right, without having to train and recompile code.
So, I mean, don't get me wrong. What we know about the ARM Zen, about the AMD Zen core, it doesn't have as much compute capability as the Intel core. You can only do one 256-bit AVX instruction per cycle. And one of the things I'm hearing is, yes, so we know this about Naples. It's not going to be in any platform that requires compute. And in any platform that doesn't require compute, you can just use either an Atom or an ARM. Is being middle of the road compute for server?
Yeah, so I think there actually is an opportunity, right? So if you look at what AMD can do with Naples is they can offer a large memory footprint, which is great if you're running like a Redis server, for example, or some other in-memory application. So you can have a large memory footprint. You can have x86 processor cores that don't necessarily require recompiling existing source code. You don't have to debug existing source code. The ability for code to just work is very significant. And so there is a very large portion of the market that if you have the requirements fulfilled of having decent single core performance without all the AVX, compute heavy workloads, you have decent x86 performance and you have a large memory capacity and you have decent IO options, that's enough to satisfy a lot of server customer needs. Specifically though, AMD is already focusing on a price battle with Intel. And so where this will get really interesting is if AMD prices Naples platforms competitively against Intel's current and future platforms.
Yeah.
Because the Intel Xeon line is a very high margin business.
Yes.
And so if AMD comes in and starts undercutting Intel in terms of margin dollars, then we're going to start seeing some very competitive deals happen in the web hosting space, which is typically one of the more price sensitive segments of the market.
Okay, but if Intel want to keep Intel in that scenario, Intel either has to lose margin or market share, or margin or revenue. Which one do you think they would prefer to lose? I mean, every time I hear an investor day, there's always talk about maintaining 60% margins, even if revenue drops, we have to maintain 60% margins. If something competitive comes out here, do you think that line would budge?
I think Intel has the ability to create differentiated products well beyond what they have today. And those differentiated products may be able to uphold a 60% margin, but it is going to require Intel change the status quo that we've seen for years. So take, for example, the Xeon E3 line, which has already had 5 and soon to be 6 iterations of maximum 4-core 8-thread processors. That is a great example of, if you think about how long that line, literally they're on V5, almost V6.
Yeah.
Right? When you think about...
It's the same with the Core i7.
It's the exact same with the lower end Core i7s.
Yeah.
Where, you see quad-core 8 threads being status quo for years. And so the question is, can AMD disrupt that market? And then what is Intel's competitive response? And I have no doubt that Intel has had folks thinking about if AMD
simulating the possibilities.
releases such chips, what are we going to do? So I do fully expect that Intel will have a competitive response.
Yeah, it's the same thing in the consumer space with when Ryzen finally hits the shelves. I mean, we know so much about Ryzen and the Zen microarchitecture apart from verified benchmark scores. It's kind of, I don't know, it's this weird thing where everybody's pleased to have competition again, as long as it's competitive.
Price competitive.
Price competitive as well, yeah. I mean, one argument that I see in general is, for some people, price doesn't matter. They only want peak performance. When you're dealing with a server where the software license costs more than the CPU, and the price, so therefore the price of the CPU arguably doesn't matter, you will pick the highest performance part that you need for your workload.
That's right.
Does AMD have any in there? I mean, assuming what we've seen, 40% IPC increase puts it around, sort of between Haswell and Broadwell, maybe, depending on the workload. When Intel coming out with Skylake later in the year.
Yeah, so I think AMD has an opportunity in terms of if they can demonstrate specific workloads for licensed software that blows Intel out of the water. I think they're going to have a really good case to.
Is this going to end up with very niche software examples, edge cases?
There can be, but there are large applications such as SQL Server, Oracle servers that those are large ecosystems, very high license cost servers, and it's possible that once we see the final numbers on the Naples platform, they may be very competitive there. At the same time, there's a huge portion of the market that runs on open source software. So MySQL rather than SQL Server.
Yeah.
Where those systems, are more price sensitive.
Yeah.
And I think that's a very large portion of the market. I think that's something that AMD could do very well in.
I mean, I know you have your internal benchmarking software, Linux Bench, that I've used for a lot of my reviews. It's going to be fun to actually get to run some of this stuff. And, arguably, I think the Naples platform is the bigger picture here for AMD. I mean, all the hype, if you stand in the consumer tech space, has all been about the consumer platform. Having something to beat, bash against Intel's Core i7 and say, hey, look, this is very price competitive. But for AMD's bottom line financially, Naples has to execute, and it has to execute well. One of the opinions of AMD has been its I want to say inability, but inability is the wrong word. It's just its general ability to execute. In the past, they've made a lot of fuss, but it hasn't necessarily panned out the way they wanted. But we look at AMD's stock price. It's now over $10. At one point, a couple of years ago, their market worth was under the value of the assets held by the company. It's a drastic change, showing that, financial investors have confidence. And if that confidence is well founded, I think we'll see fairly soon. But I still think Naples is going to be the bigger, the better for the bottom line.
Yeah, and I think the other thing to look at is that Intel has been conceding market share in the overall consumer device space for some time.
So, to ARM.
To ARM, and so AMD's initial attack into the workstation market, is specifically going at a portion of Intel that Intel has been moving away from. Just
letting it settle, essentially. I'm going to kind of wrap it up there, because it's extremely late at night and busy times ahead. But thank you, Patrick, for coming onto the podcast.
Thanks for having me.
And guys, if you've never read ServeTheHome, go check it out. I read it. You have access to all this stuff.
We do.
And it's good to see benchmark numbers all the time. Again, thanks, Patrick, and thanks everybody for listening.